Hello, good day everyone. I hope you're having a nice time there. And in this class, we are going to look at something special in mathematics, and it's going to be on indices. So, but before then, please, I want you to always subscribe to my YouTube channel, Mathematics Workshop. There you will find a lot of interesting topics which I've already uploaded on my YouTube channel. Please do help me subscribe to my YouTube channel and always make sure you also help me to share to other group. Thank you. Like I said, in this class we're going to look at indices. 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 It's a very special topic. You know, it's a bedrock in mathematics. So we are going to look at it. We're going to take a general view, a bird's eye view, look at the introductions, and look at how it operates, especially the laws of indices. But before then, let's look at some things. Assuming we have, let's say, x raised to the power a, this one simply means s times x times x. That means 8 factors. It means s is multiplying itself a number of 8 times. That is the meaning of what is on the board. Assuming we have another, we'll say x raised to the power b, and this simply means s times x. This is called b8 factor. It means that b is multiplying itself. I mean, s is multiplying itself a number of b times. That is the simple meaning of x raised to the power this. Now, let's now understand. We have an a here. The a here is called index. If it is only one, we call it index. Sometimes you can also hear people saying exponent or power. So those are the terms. If it is one, it is index, exponent, or power. Then the x here, we refer to it as the base. We call it base. Then for instance, you know, we have a index, another index here. So if the index are if the index are more than one, we refer to them as indices. Refer to them as indices. So for instance, we have if I exponent here, e.g., look at exponent here, a and a comma b. So if we have two exponents, we no longer call them index, they become what? Indices. So the plural of index is called indices. Then let's look at some definition of terms. Like I said, index. The index, another word for index, like I said, is exponent power. This is the number of time a given expression is raised. So how many times an expression is raised? Expression here could be your number here is raised. For instance, if we have 5 raised to the power 4, it simply means 5 is multiplying itself 4 times. So this is 5 times 5 times 5 times 5. That is the meaning of this. So here, this is just one index. Okay, then that is one definition. The second definition here, let's look at indices. This is the plural of index. It is the application of mathematical concept of exponents or powers. So that's the meaning of indices. The singular, if we have one of it, is index. More than one, we refer to it as indices. So I have given some definition of them. So for here, let's look at example here. We have 5 raised to the power, let's say 2 times 5 raised to the power 4. You see that the you see this exponent here, another exponent which is index, so there are more than one. So here simply means 5 times 5, then times 5 times 5 times 5 times 5. So the basic operations or the basic application of a mathematical concept of exponent or power is known as indices. It's known as what? Indices. So in this class, like I said, we are going to look at the laws, the introductions, and those things that we need to know. We're going to look at different laws that govern, or different rules that govern the operations of indices. So indices is very important. Very important. It has a relationship with logarithm. So if you want to understand logarithm thoroughly, you must be able to do what? To understand the indices. Now, this next thing we're going to look at here, we're going to look at the basic law of indices. So we're going to look at laws. So the basic law of indices are premises on our operation sign. Operation sign of addition, operation on addition, multiplication, division, and so on and so forth. So they have relationship. When it is addition, when it is multiplication is addition, when it is division is subtraction. You know, we are going to look at that. Now let's look at the laws of indices. First, the first law. See that if we have x raised to the power a times x raised to the power b, since the base are the same, what you need to do, we take the base as 1 and add the each of the index, which is the indices. So multiplication we add. Multiplication we do what? We add powers or exponents. So if in a given this indices, if the operation sign here is multiplications and the base are the same, what you need to do, you take the base as 1, as a single one, and add the exponents. Okay, then law 2, we have x raised to power a divide, for instance, s raised to power b. Here, if the operation sign here is divisions and the base are the same, what you do, you say take the base as 1 and subtract the exponents. So please be careful in this division sign. This is the one you write first. It should be this minus this. Don't write this minus this. Okay, that is. Then we also have another law here. If we have s raised to power 0, anything raised to power 0, any number raised to power 0 here is equal to 1. Then we also have law 4. If we have x raised to power 1 over a, it simply means the 8th root of x. The 8th root of what? X. Take note, if your if a is equal to 2, it means that this expression will reduce to just the square root of x. Take note. But if apart from a is equal to 2, every other one you must put it here. If a is 3, you put a cube root. If a is 4, you put fourth root, so on and so forth, except 2. Then we have the 5th law. We have s raised to power a, s raised to power b over a, and this one means the 8th root of x, all bracket raised to power b. Raised to power what? B. This is the 8th root of x, or the bracket raised to power what? B. Then if we have x raised to power minus a, which is negative indices. All these ones, they are called the root what? Indices. This one is negative indices. Simply means 1 all over what? S raised to power a. For instance, if we also have this s raised to power minus b over a, here it simply means 1 all over x raised to power b over a. Okay? Then 7, if we have, for instance, x raised to power a all over s raised to power b, all in bracket, and we also have another exponent here, say c. So this one simply means s raised to power a times c all over what? s raised to power b times c. So this c, which is also an exponent that is outside, was also multiply the exponent that is inside. So all these ones are just extended laws of indices. Then we have a number 8. We have s over y, for instance. We have s all over y raised to power minus a. This one simply means y over x, all raised to power a. So in this place, what this one simply means from our law here, from our law that says if you have a negative indices and this was supposed to be x over y. Let me write it properly. This is supposed to be 1 over s raised to power a all over what? Y raised to power a. So we're having a division sign here, which means 1 divide s raised to power a all over what? Y raised to power a. And you know, normally what you need to do here is you change this division sign to multiplication, and by doing that you are going to invert, you are going to look for the reciprocal of this whole expression. So here it becomes 1 times y raised to power a over s raised to power a. That's why I wrote y over s all bracket raised to power a. So this a will also affect everything inside, and it will reduce to this. So these are some of the laws. These are the ones that, you know, they are very key to the operations of indices. So in this class we take some few examples, and in our previous class on this we will come up with more of these operation of indices. So the first law here, we have known it. If it is multiplications, if the base are the same, you take the base as 1 and you add the powers or the indices. Then if the sign is division and the base are the same, take the base as 1, add, and you subtract the powers. So anything raised to power 0 here in mathematics, any number raised to power 0 is equal to 1. You have s raised to power 1 over a, it means the eighth root of x. But take note, if your a is equal to 2, we term it as what? The square root. Okay? So if we have, this one is the root, this one is the root indices. These 2, 4 and 5, they are what? Root indices. So if we have s raised to power b over a, it simply means the air root of x, of the number of the given expression or number, everything raised to power what? To power b. So this is negative indices. The negative indices says, if we have a negative indices, is 1 all over s raised to power what? A. And that will be our answer. So we have all this one, they are just extended forms of the law of indices. Very important. So let's do some basic operation. Let's look at the example. Simplify 4 raised to power okay, so we should do this. Simplify this. Or as you can see, you see that they don't have common base. But this number we can express them in as a common base using prime numbers. Or if we don't want to do that, we can simply use from the law, we say that x raised to power 1 over a is equal to the 8th root of the number. We can use this particular law to do this operation. So, okay, now if we say 4 raised to power half, it means, like I told you, I say any moment a is this, you call what? We refer to it as what? The square root of 4. So the square root of 4, how many times Which number will multiply itself twice to give us 4? Which number will multiply itself twice to give us 4? That will be the square root of 4. Or if we don't want to do it in that manner, we can simply say that this 4 means expressed as 4. 4 means 2 times 2. 2 times 2, which is 2 raised to power what? 2. And here we have another. From the law, we said if we have x raised to power a bracket b, it simply means x raised to power a times what? B. The power outside will multiply the inside. So this is the new power multiplying the old one. So this will go with this. And what we have here, 4 raised to power half becomes what? Becomes 2. So let's come with 8. So this is for 4 raised to power half. Then let's come to 8 raised to power 1/3. So we're going to express this how many as a prime factors. Prime factor of 8. That means prime factors are those numbers that has only 2 factors. So here now we can express this one as a prime factor of using 2. So 2 is a prime factor, and it's a prime number, and a prime factor of 8. It means 2 will multiply itself 3 times. 2 times 2 times 2. Everything raised to power what? 1/this. So here, this one simply means 1, 2, 3. So it means 2 raised to power what? 3. Times the one we have here. This will go with this, and our answer here become 2. So here, 8 raised to power 1/3 is equals to 2. So let's try 16, expressing 16 as a prime as well. (16) raised to power 4. This one means 2 times 2 times 2 times 2. How many times will 2 multiply itself to give us 16? Is 4. 1, 2, 3, 4. Everything raised to power 1/4. So this one means 1, 2, 3, 4. It means 2 raised to power 4 times 1/4. This will go with this, and our answer is 2. So 16 raised to power 1/4 is equals to 2. And if we put them into our expression, say we should simplify this, it simply means here is 2 times 2 divided by what? By 2. So here, you don't need to waste time, you can, our answer is this. So you can say therefore, 4 raised to power 1/2 times 8 raised to power 1/3 all over 16 raised to power 1/4 is equal to 2. So the first thing you need to do is make sure if they have a common factor, you express them as their prime factors. Now you do each of the operation, and you see that it will work. But if you don't want to do it like that, like I said, if you have anything in there, this has to do with this. So we just here is square root of 4 is what? Is 2. When you express this one now, how many times will 2 multiply itself to give us this? This is the square root of 4 is 2. So if you are looking for the cube root, the other one is 8 raised to power 1/3. It means the cube root of 8. How many times will 2 multiply itself to give you 8? Is 3 times. So that is the meaning of cube root. So the fourth root of 16 simply means how many times will 2 multiply itself to give us 16. So by the time you apply all this, you will find that your answer will be this. Okay. Let's take some more examples. Example 2. evaluate 81 Okay, so we should do this. So here we have 625 raised to a half, divide 81. So what we need to do here, you see that these numbers, they do not have something in common, but they say you should do something, you have to simplify. Evaluate it. So here, this 625 simply means the square root of 625. So we ask ourselves, which number will multiply itself twice to give us this number? That will be the square root. So here, what we do here, sometimes we use prime number, the prime number that can divide this. Among our prime number here, we have 2, 3, 5, 7, 11, 13. This is very key here. You know, we have to understand prime numbers, especially when we are operating indices. So we look at this one. Which one can divide this? Is 5. 5 here 1, 5 here 2. Okay. 5 here. Okay. 5 here 25. 5 here 5. 5 here 1. So if we look at this now, it simply means 5 square times 5 square. So if we put all these together, this one means 5 times 5 all square, and we're having here. So this will give us 25. So the square root of 625 is what? Is 25. I've gotten that? Okay. So I've closed this. So let's look at this 81 raised by 1 over 4. So we're going to look at this one means the fourth root of 81. We're going to ask ourselves which number will multiply itself 4 times to give us 81. So we can only do that by using a factor of 81. We look for which number that can divide 81, a prime number that can divide 81. So if you look at from here now, this one can divide it. How do you know that 3 can divide it? If you add 8 plus 1 is 9. So for you to know that 3 can divide the number, just sum the number together. If 3 is a factor of the number, that means 3 can divide it. So let's do that. 81. So we have 3 here. 3 in 8 is 2, remainder 2. That is 21. This is 7. So 3 here is 9. Yes, 3 here is 3, and 3 here 1. So this one means 1, 2, 3, 4. So that's typically state that this 81 is 3 raised power what? 4. You know we're having 1 over 4 times 1 over 4. This will go with this and this. So our answer here in 8 raised power 1 over 4 is what? 3. So we say we should simplify here. It means 625 raised power 1 over 2 divide 81 raised power 1 over 4 is equals to 25 divided by 3. So here you can put your answer in a mixed number. So here will give us how many 3 can we get in 25? That will give us 3 times 8, 24. So it's 8 whole number, 1/3. This is our answer for that. So this is indices. This is just introduction. Please wake up time, go and study the laws. In our next class, I will be coming with more and more questions. Have a nice time. See you in our next video. Thanks.